Okay, well, I'm going to be discussing NCTM's Focus in High School Mathematics. And this focus document was dealing with reasoning and sense making in the secondary classroom. And it really highlights the importance of both of these elements in our classroom and in students, not only in the classroom, but also throughout their life, future employment, and also future study. One of the reasons this has become a more important thing in recent years is because in several studies it's showing that the U.S. is really lagging behind in these reasoning abilities. Also, reasoning and sense making really do provide the foundation of many of our process standards. Now, in the past, we focused on reasoning only as the more formal reasoning skills, but it also includes those informal explanations, the justifications, as well as the inductive reasoning. And we're seeing this more in our assessment strategies, the emphasis on explaining mathematical thought. In the article I read earlier this term, it was in teaching children's mathematics, and even though it focused on third graders, again, you have this greater emphasis on student reasoning and writing about mathematical thought at a very early age. And so we see, even though we're dealing with reasoning and logical thoughts and proofs, there are several ties between other process standards. The sense-making aspect they define as developing an understanding of a situation, a context, or a concept by connecting with it with an existing knowledge. And so this is, again, you've got both the informal and formal reasoning skills going hand in hand, and they do go across a continuum. You have to have those informal reasoning and sense-making experiences early so that later on you can develop formal proofs. Now, in our classrooms, especially at the secondary level, we really need to be integrating this in daily use. What's going on here? Why do you think that? Constantly asking questions to make children explain what is going on in their mathematical thought. And the key really is self-experience, not just observation, taking it to the next level, letting them see what they're doing so that they can develop the algorithms for themselves. Now, there are several things we can do to build these, several of these reasoning habits. You have to have the fluency with the reasoning skills. It should be a natural process, and it needs to continually develop and expand. They said that you need to demonstrate growing levels of formality in their reasoning in their classroom, in their oral and written work, and in the assessments throughout high school years. So this really needs to be part of the fabric of all curriculum, and especially statistics, technology, and math models. Some more areas that we can develop our reasoning habits are looking and analyzing a problem. We need to look for hidden structures, look for patterns and relationships, consider any special cases, make those connections. Another issue is the initiating a strategy, selecting mathematical representations, making purposeful uses of procedures, and organizing these into solution. You've got to develop the ability to monitor one's. They've got to get to the point where they're seeing the mathematical connections between what they're doing and the actual work that we're trying to get through. Make the connection between the mathematical model and the algorithm. And finally, they've got to develop that self-reflection area to be able to explain their own thinking. Of mathematical proficiency. The first is conceptual understanding, which is our comprehension of mathematical concepts. The second is our procedural fluency, and that is the skill in carrying out procedures flexibly, accurately, efficiently, and also appropriately, knowing when to use them. The third is that strategic competence, and that is our ability to formulate, represent, and solve mathematical problems. Fourth step is the adaptive reasoning, and that's our ability to have the capacity for logical thought. And finally, we have productive disposition, and that's the habitual inclination to see mathematics as sensible, useful, and worthwhile. Along with seeing how this plays out in the actual classroom, the focus document also looks at the reasoning and sense-making elements in the curriculum. Instead of a reteach at the beginning of term, emphasize reasoned connections with prior knowledge. Focus on coherence with the curriculum. While there is some trepidation adding any new standards to what seems to be an already packed curriculum, and this does seem to be adding just more to what is already a lot to deal with as a teacher, the focus document did offer some ways to actually create instructional time rather than simply impeding it. And so these ideas of the reteaching, the reason connections really did seem to help out. For example, when you're dealing with numbers and measurement, talk about the reasonableness of answers and measurements. Okay, this is something that you can go back and maybe not have to reteach later. Deal with approximations and error. Talk about real world settings. When you're discussing number system, talk about the foundation for the development in algebra. Understanding number system properties deeply. Extending the number system properties to algebraic settings. And last, when we're dealing with counting and order being relevant, recognizing when enumeration would be a productive approach to solving a problem. Now, in the area of algebra, when we're dealing with the meaningful use of symbols, we've got the ability to create expressions. We've also got the ability to distinguish those variables and constraints. Reasoned problem solving, seeing the solution steps as logical deductions from equation, interpreting solutions in a context. And all of these really are ways that you're not adding to the curriculum. These reasoning and skills sense-making standards are not just another thing you're having to teach. They're already in there, and you're just teaching what you already would be from this perspective. And so you are connecting algebra with geometry, but these are important connections that really will come back and make it a lot easier for you later on. Reasoning with functions, you've got the multiple representation representing functions in a variety of ways, graphic, visual, verbal. When you're dealing with the families and the function families, working to develop a reasonable mathematical model for a particular context really does help students grasp on to the idea. And analyzing the effects of parameters, using a general representation of a function in a given family, and then analyzing the effects of varying the coefficients and seeing what it does. In the area of geometry, we've got conjectures about geometric objects, and that's when we're analyzing the configurations and reasoning inductively. It also provides a common, interesting, and recognizable situation in which students can really immerse themselves in mathematical analysis. When we're dealing with the multiple geometric approaches, we're getting to analyze the synthetic approaches, and the coordinate system. And then you've also got the geometric connections and modeling. And the probability and statistics with data analysis, you've got using graphic and tabular representations and modeling randomness. You're developing probability models to describe the long-run behavior of random process, connecting statistics and probability. We're recognizing to the curriculum. It's a new perspective on what we're doing. So you're still teaching the same content, but you're teaching it from a reasoning and sense-making standpoint. Now, one area that's been very important in our class is the issue of equity. We have very, very diverse classrooms, and so making sure that can provide an equitable and fair education to all of our students is of paramount importance. And this is one area which is, especially since student demographics, and that really is the biggest thing I got out of it, was they are too often predictive of the opportunities students have for reasoning and sense making. The students who grow up in much more grounds and higher SES status really have a much easier time with this because they've been given multiple opportunities. And because it is so central to what we're teaching, it does put those students who come from a background where that is not first nature it makes it much harder on them. And so that means we must be that more diligent to provide that equitable atmosphere for our students. In the area of cohesion, to make sure that our curriculum, our vertical alignment, and our assessment are lining up. Reasoning and sense making across the curriculum have to have a structure, and they have to have a sequence. The classroom should be on student thinking and reasoning. The idea of the focus document is you have your content curriculum and you are looking at that through the lens of reasoning and sense making. And they also just assessing what is valued. This is something that the state of Texas is working very hard to do. The implementation of STAR as a new test is supposed to provide a much greater, we're supposed to be doing concept-based testing. The area they looked at was the stakeholder involvement. And they were talking about all the different people who really do have a stake in what is going on here. The big questions among the lines of communications open. Are they being established to promote mathematical reasoning and sense making as central goals of high school mathematics? And these are questions that we really do need to think about. We need to be thinking about if the collaboration among us as teachers, our students, their parents, our administrators, our professors, we need to make sure that reasoning and sense making is a central focus. Is it a feature of our efforts to improve high school curriculum? Is the importance of developing learning communities that collaboratively seek continuing improvement across the educational system recognized? And lastly, is each group of stakeholders identifying both long and short-term plans in consultation with each other and beginning to implement those plans? Those were a few questions I wanted to leave you with tonight. I also wanted to talk about a couple of resources that I've been able to find along these methods. One is a problem-solving method that ties in and justifying one's answers in problem-solving situations, and it is called a QDPAC. Q stands for question, D stands for data, P stands for plan, A stands for answer, and C stands for check. Students across grade levels to really look at what is the problem asking me to do, what are the important what's the important data, what's my plan for solving it, how do I answer it, and then how could I go back. And so in this way they're getting to write about their mathematical thought. Another is a FRAIR model. This is very helpful in our situations with vocabulary, and in addition to having the word and coming up with their own definition, students or characteristics about the word, as well as examples and non-examples. And the last thing was, just did want to call the attention to, NCTM did release a writing rubric with their teaching mathematics, and so if you're interested in that, please let me know and I will be happy to send that to you. I adapted it for my 6th graders, but it would be very, very easily adaptable for any grade level, and it really does give you a tool to help your students how to write and justify their answers in that informal process so that they can develop those proofs later on. Thank you for listening, and again, focus on the idea of the interaction between these stakeholders, conversation about what is going on, and we are keeping in mind the importance of reasoning and sense making, that we're looking at our curriculum through that lens. Thank you.